Okay, so here we go for Geometry B. We're looking in your new packet. On the front it says 9.1 solid figures, and then I think you would have gotten now a little half sheet of paper with assigned problems here. I'm going to look at certain problems from this packet, from this first section specifically. So the first section, the 9.1 exercises, this is in on pages 476 to 480. So I'm going to start with exercises 4 through 9. A lot of this is going to be vocabulary. A lot of it is just going to be understanding what they are even talking about here. So first thing, when we talk about this shape, it says, sorry, let me start with the instructions. In exercises 4 through 9, tell whether the statement is true or false. Refer to the prism below, so this prism right here, if necessary. So one thing with these prisms is it is sometimes helpful to think about a prism, P-R-I-S-M, prism, not prison, prism, as a room. So if we think of a prism as a room, most rooms are what we would call rectangular prisms. But there's three things we can talk about. So we can talk about, the first thing they mention here, number 4, they talk about a face. And I don't want that underlined or italics. That's a face. I don't want to underline that. There we go. A face. A face of the prism. That's what number 4 says. It says CDHG is a face of the prism. So when I think of a room, the face of the prism would be a wall of the room. So if I look at this statement here, and I ask myself, okay, CDHG, if I trace out those letters, wrong way, CDHG, and then we could go back to C, that does look like it would be a wall of the room. So that statement there would be true. CDHG would be a face of the prism. Okay, so just practicing that vocab, the face of a prism, or a face of these things in general are what we call polyhedra. What a lot of these are what we're going to be studying. Excuse me, but the face is like a wall of the room. Okay, so number 4 is true. CDHG is like a wall of that prism. Number 5, a prism has only one base. Now bases, that's another thing we can talk about if we think of a room. So when we talk about the bases of a prism, we talk about opposite walls. Now there's lots of pairs of opposite walls. So we could have, for example, we could have the floor and the ceiling could be bases, or it could be the north wall and the south wall. That's another possibility. Those would be opposite walls if our room is set up that way. Or it could be the east wall and the west wall. But here basically the idea is for a prism we do not just have one base. We would have 2 bases. The floor and the ceiling, that's 2 bases. Or the north wall and the south wall, that's 2 bases. Or the east wall and the west wall, that would be 2 bases. So number 5 would be false. We do not have only one base on a prism. Other shapes called pyramids, which is in this section, but pyramids would have only one base. A prism has 2 bases, floor and ceiling, or north wall and south wall, or east wall and west wall. I'm usually going to talk about the floor and the ceiling as the bases. Number 6 talks about bases again, so we can use this idea of opposite walls. I like the floor and the ceiling, but we'll see what they do. So number 6, they talk about A, B, C, D, and again, if we trace those letters, A, B, C, D, and then we would go back to A, that would be a wall, it looks like. That looks like it'd be the ceiling. And E, if you can see F is right there, E, F, G, H, and then we would go back to E. Those are possible bases of the prism. So I go, well, the way it's set up, it looks like it would be the floor and the ceiling. So I go, yeah, that would be accurate. That would be true to say that they are bases, possible bases. It didn't have to be the floor and the ceiling. We said it could be the floor and the ceiling or the north wall and the south wall. In this case, you might think about the front wall and the back wall, or you could say that would be a pair of bases, or the wall on the right and the wall on the left. That would be another pair of bases. But here they gave us the top and the bottom, the floor and the ceiling, and those are possible bases. So now more with prisms, and let me scoot this here so I got a little more room. Other things we can talk about with these prisms is we can talk about edges. So an edge of a prism, that is where two walls meet, or two faces. Since the walls are the faces, it's where two faces meet. So I guess we could say that as well. Just to stick with our geometry vocabulary there, we're going to call them faces, but we can think about walls. So it says an edge of the prism is H. Now when they say H, they're only talking about a single point. They're just talking about H right here. And I say, well, I guess it's where two walls or where two faces meet, but this should be only two walls or only two faces. This might be better described as like a corner of the room or a corner of the prism. There's more than two walls or there's more than two faces. There's, the way I have it here, it's the front face. ADHE is meeting DCGH is also meeting EFGH. So we have three walls or three faces that are meeting here. That is not an edge. An edge is only two walls or only two faces. So that one is going to be false. So just to finish up there with number 7, if you said, okay, well, H is not an edge, that's false to say it's an edge. So you say, well, what is it? It's what we would call a vertex. And the plural of vertex is vertices. So the three basic things we'll talk about with these shapes that we're going to start studying here, we'll talk about faces, we'll talk about edges, and we'll talk about vertices, or a vertex or vertices. Really, we'll say vertices plural. Now, a vertex you can think of as a vertex is where three or more walls meet. If you're thinking about that room analogy, three or more walls are meeting. It could be sometimes, depending on the shape, it could be 4 walls or 5 walls that meet there. In this case, we said it was 3 walls that meet at H. It was the front wall ADHE, the right wall DCGH, and the bottom wall or the floor, I guess, EFGH. So more technically, where 3 or more faces meet. Now, an easier way that might help you to remember this, my middle school math teacher taught us this. He called the vertices, he called them the ouchies. The ouchies, because like if you actually had this shape, and I do have some of these shapes in the classroom, like you can kind of poke yourself on this point H, and it would kind of hurt. So when you do that, you might exclaim, ouch! So, because it hurts. So he called them the ouchies. So if that vertices, if you think ouchies, if that is easier for you, great. If it doesn't work for you, then you have to figure out your own silly, stupid way to do that. But let's finish up here with 4 through 9. So now, next we have GC is an edge of the prism. So GC, we've got right here. And when I look at that, I go, well, let's see. Again, my definition for edge, where 2 walls meet, or where 2 faces meet. And I go, yeah, that is where 2 faces are meeting. We would have the right wall, DCGH, or the right face, DCGH, and that meets the back face, or the back wall, BCGF. So yeah, so that one is true. And then the last one on here, a prism, we have an example of a prism here. A prism is a polyhedron. So we haven't, in this video, we haven't exactly defined a polyhedron, but essentially I'll say this for a polyhedron. It's a 3-dimensional shape, and we'll talk about that a little more in class. It's a 3D shape. And basically there's no curvature, there's no round parts to it. Now, no, I'm just going to say no round parts. Now there's more to this. We have to be careful. We don't want to oversimplify, but it's a simple definition to say a polyhedron is a three-dimensional or 3D shape that has no round parts. We need a little bit more than that, but when I look at this prism, I go, yeah, it's three-dimensional, and there's no round parts, there's no curved portions to it. So this would be true to finish up here. Number 9 would also be true. Okay. And we'll hopefully in class we'll describe or define a polyhedron, or the plural there is polyhedra. We'll define that a little bit better. And in fact, the next 3 questions we'll look at, 10 through 12, ask us if our shape, our solid shape, is a polyhedron. So we'll get some examples there as well. So continuing on with 10, 11, and 12 here, now we're talking more about these things called polyhedra, singular polyhedron. So tell whether the solid is a polyhedron. If so, identify the shape of the base or bases. Then name the solid. So here we go with 10, 11, and 12. It says tell whether the polyhedron is, tell whether the solid is a polyhedron. If so, identify the shape of the base or bases, then name the solid. So again, polyhedra, that's the plural. Singular is polyhedron. Math, or excuse me, English is great. Ask your English teacher why it is that way. But a simple definition for a polyhedra, it's three-dimensional shapes with no round parts. So when I look at number 10, it looks like it is a polyhedron. So we'll write that down here. Number 10 is a polyhedron. Whoops, let's just switch to the pencil. So 10 is yes, a polyhedron. Okay, we'll come back and we'll talk about identify the shape of the base or bases and then name the solid. But right now we'll just do that. Is it a three-dimensional shape? These are all three-dimensional shapes, what they sometimes call a solid shape, but no round parts. So number 10, I don't see any round parts in there. Number 11, is it a polyhedron? Well, I see kind of like a circle or an oval or something, and that's round. So I would say here number 11 is not a polyhedron. Not a polyhedron here. I can still talk about a base or bases if I want to, but because of this round part, it is not a polyhedron. It actually says, if so, identify the shape of the base. I'll still identify that, but it's not a polyhedron. And then number 12, to finish up for this, is it a polyhedron or not? Again, it's a 3D shape. I don't see any round parts. So for my simplified definition, this is a polyhedron. Okay, so that's whether or not it is a polyhedron. Number 10, yes. Number 11, no. Number 12, yes, it is a polyhedron. When we look at the base for each one now, the base, and again, I'll even do it for number 11. The base, if you remember, we said the base would be like opposite walls in a room, like the floor and the ceiling. So number 10, it's kind of hard to tell, but you got 4 sides for the top, and the bottom's even harder to tell, but there's 4 sides on the bottom. These little dashed or dotted lines represent edges where 2 faces meet, or 2 walls meet. Represents edges where or that can't be seen. The little dashed lines are things we can't see. So all of these pictures have little dashed or dotted segments, and it's like, well, you wouldn't be able to see that, but we still want to let you know that they're there, since it's on a flat piece of paper. So if I talk about the top and the bottom here, it looks like they're 4-sided shapes for number 10. We could call them quadrilaterals, but here we're going to assume that these are rectangles. And there's 2 of them. We have 2 rectangles. So when it says identify the shape of the base and then the parenthesis S, meaning or bases, we have 2 rectangles here. Okay, then for number 11, I said I would still do the base or the bases even though it's not a polyhedron. And we have, it looks kind of like what you might call an oval or an ellipse, but really I believe this is probably supposed to be circles. It's just that we're looking at it at an angle, so I believe we're supposed to have circles as the bases. There's two of them. There's a circle or an ellipse, so a round shape on the top and another on the bottom. And then for number 12, here we only have one base, and it's what I would call the bottom there, and it has 1, 2, 3, 4, 5 sides. And if you remember, a 5-sided shape is called a pentagon. Pentagon is a 5-sided shape. Okay. So then the last part here is to name the solid, and we're doing that even for number 11. Okay, and if you have your, I think you have a little note sheet with some of these three-dimensional shapes on them. You might be able to match them up from that. But number 10 is what we would call a prism. And I'm going to leave a little space above that because I'm going to give a description of what kind of prism. But for right now, I'm just going to call that a prism. And let me clean that up a little bit. My R didn't look very pretty there. So number 10 is what we would call a prism. For me, that's fine. You call it a prism, I'm good with that. We can be a little more specific. We can say what kind of prism, but for right now I'll just leave it as prism. Number 11, this, when you have circles as your bases, this is what's called a cylinder. And as far as I typically study, there's only cylinders. There's not certain different kinds of cylinders. So when you have a circle on the top and a circle on the bottom, that is typically a cylinder. And then number 12, I think I may have mentioned, is a pyramid. And you might be familiar with like the pyramids of Egypt. So this kind of looks like that. It's a little bit different, but it comes to a point at the top. So if we think about a room again, number 10, you've got a floor, you've got a ceiling, and then you've got 4 walls. That's called a prism. Number 12, you could say you have a floor in the shape of a pentagon, and you have walls that are triangles, but there is no ceiling really, because all those triangles meet up at the top. Okay. So for me, as far as this class goes, I'm fine if number 10, if you just say prism, number 11 cylinder, and number 12 pyramid, I'm fine with that. But we can get a little more specific if we want to. Because number 10, the bases are rectangles, we can call this a rectangular prism. So to take that word rectangle as a noun, and the related adjective is rectangular. So the best name you could give this is a rectangular prism. Again, I'm okay if you stop at prism, but a rectangular prism instead of a triangular prism or some other kind of prism. Number 11 is just a cylinder, but then number 12, when you have a pentagon for the base, the name we can give that is, we can say it's a pentagonal. Oops, let's write that a little bit nicer. A pentagonal pyramid, if you wanted to be a little more specific. Again, pyramid is fine, but a pentagonal pyramid would be the best description you could give for this.